All right, for geometry lesson 3.5 notes, we're talking more about parallel lines, but this time we're adding in triangles. So postulate 3.2 is the parallel postulate. What it states is that through a point that's not on a line, there's only one line that could be parallel to another line. So as long as this point is on a different line, there's only one line that can be formed that goes through point P that would also be parallel to a separate line. So it reads, there's exactly one line through point P that is parallel to line L. Okay, so you couldn't also have one this direction. There's only one possibility of a line that would be parallel to another line through a particular point. Okay, theorem 3.11 tells us the triangle angle sum theorem. I'm sure you probably already know this one, but we're going to refer to it today, and that is that all three angles of a triangle add up to 180 degrees exactly. So the measure of angle A plus the measure of angle B plus the measure of angle C equals exactly 180 every time. Doesn't matter if it's an acute triangle, if it's an obtuse triangle, if it's an equilateral triangle, all of these always add up to 180. All right, using the angle sum theorem, the triangle angle sum theorem, find the values in number 1 of x and of y and of z. So let's start by looking at just angle x. If we know that all triangles add up to 180, all you would have to do is take 43 plus 59 and subtract it from 180, and that gives us x, which is 78. So x would be 78 degrees. All right, now, knowing that x, it's really hard to write in that little space. Knowing that x is 78 degrees, how can we find angle y? I hope what you're looking at me doing is you're seeing that I'm making a linear pair. X plus y are on this straight line, which is from A to C, and straight lines also add up to 180. So we can figure it out because if x is 78, y would be added to 78 to make a 180 degree linear pair line, and that would be 102. Okay, and then lastly, if we know that y is 102 and we know that up here is 49, then we can just subtract 102 and 49 from 180 to get z, and that would be 29 degrees. All right, we've got some key vocabulary you need to write down here. So the exterior angle of a polygon, this is kind of new. We haven't really talked about that. It's out here. It would be like number 1 out here. It's the exterior angle of a polygon. So that is the angle formed, angle that is formed by a side and an extension of an adjacent side. Adjacent, remember, means right next to it. So this picture down below really clearly shows it. The exterior angle is the extension of the line formed off of this triangle. Okay, and then remote interior angles, that would be like what 2 and 3 are. So it's not the angle that is right adjacent to the exterior angle, it's the other two. Those are called remote interior angles. So the best way I think to write the definition is that for each, I hope this is the best way to say it, I hope it makes sense, for each exterior angle of a triangle, the two non-adjacent, the two that are not adjacent. So again, the two that are not right next to it, but these other two, the two non-adjacent interior angles is what those are. Are these? I don't know. I guess I shouldn't have really said, I shouldn't have started it like these. I should have started, these are the two non-adjacent interior angles for each exterior angle of a triangle. So again, let me just show you with the picture. One is the exterior angle, 2 and 3 are the remote interior angles. It's not adjacent to the exterior angle. Okay, so here's our triangle exterior angle theorem. This is a new one. This is theorem 3.12. So what it says is that the measure of angle 1, which is this one, interestingly enough, it equals the sum of the other two remote interior angles. So this angle 1 equals 2 and 3 added together. And if you think about it, it makes sense, because if all 3 in a triangle add up to 180, then these two added together make almost 180. It would be whatever's left here. And whatever's left here is connected by a linear pair to this one, which would make up these two added together. So I hope that makes sense. All right, using this information, we're going to find out what exterior angle 1 is and remote interior angle 2 is in these two separate problems. So number 1, you can either figure this out by knowing that the remote interior angles add up to the same thing as this, or you can go triangles add up to 180, so therefore I can subtract these from 180 and whatever's left goes here, and this makes a linear pair with number 1. That seems like a little bit more work, so I'm just going to add 180 plus 18 is 98, so I know that angle 1 equals 98 degrees. All right. I'm going to do the same thing here. I could do a linear pair, and then once I know this plus this have to equal 180, and that's fine. Or I know that this equals these two added together. So it's a little bit quicker to do a one-stop shop and say 124 minus 59. 124 minus 59 is 65 degrees. All right, let's look at the back. So on the back, there is a picture of this airplane coming in, and the tower that watches for the airplanes as they come in. So it's a multiple choice problem. It says when radar tracks an object, the reflection of signals off the ground can result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. At the right, there's a radar receiver at A and an airplane at B, and the airplane's ghost at D. Like, it's almost like reflects. It's a reflection, which is what it says. Okay, what is the value of X? So this one actually worked it out for you. It's multiple choice, but it worked it out down here for you, and it said that X equals 50, so it would be this one. But be sure you look at Y, that A plus B equals angle BCD. So this angle here is 80. That's the remote exterior angle, or sorry, that's the exterior angle, and these two are the remote interior angles. So we could just subtract. If we know they add up to 80, 30 plus 50 would be that 80. Okay, and then the last question, could you do it a different way? Well, based on what we talked about on the front page, yes, you could do 30 plus this linear pair would be 80 plus 100. And we know that 80 plus 100 make a linear pair, but 100 plus 30 plus question mark X equal 180, because all triangles add up to 180. So I could have also subtracted it by the triangle sum theorem. I'm not going to write that all out, but the answer is yes, you can do either one of the two theorems we've talked about today.